Today is day 16, AMI 17. So it is April the 14th. We are on our 16th day of being away from the classroom, and we are working on AMI 17. And we are in physical science class looking more at force acceleration. Today we're looking at Newton's second law of motion. These are not new concepts. These are concepts that we have previously learned, and I don't know why that threw that back down. Things you're going to need today to complete today's work or today's assignment. You are going to need the worksheet 6.2 Newton's second law. If you don't have availability to print it off, you can get a piece of paper, name, class, AMI day, top right hand corner. So your name, physical science, and then day 17. Need a writing utensil, and you will probably need a calculator for this. If you can remember how we found acceleration, we were doing 3-point equations, and there will be division and multiplication of fairly looks like large numbers. So you do need a calculator. Grab a phone, grab a calculator, grab your dad who can do good mental math. Assignment for today is to read through the practice example problems, which you're going to do together, and then complete numbers 1 through 7. Let's do a quick reminder of what Newton's first law is. I know that this yesterday was not really an introduction to it. It was just a reminder of what Newton's first law is, where Newton's law says an object at rest stays at rest unless acted upon. An object at rest stays at rest. An object in motion stays in motion, and those have two counterbalance forces, and those two counterbalance forces, when they are added together, create a net force of 0, because you've got a positive force and a negative force, and they should create a 0 if it's at rest and if it's at constant motion. And so there is our net force, talking about how it stays at a 0 if we've got an object such as this roll of tape. And I know it's crazy, I've got this roll of tape beside me, but if it's at rest, right now it's got the weight pushing down, gravity pushing up, or normal force. Those two act together. In order for it to stay at rest, they must have a force of 0. Oh my, I forgot to erase all this lovely stuff, but that's okay. We can go right through it. Remember, we had the Camaro. The Camaro itself, we look at the x-axis. It has its driving force. It's in a positive motion. Has air resistance, which is in a negative motion. Those two together, as long as it's at a constant velocity, say it's going 65 miles per hour, or some of you boys would like to go 115 miles per hour at a constant velocity, which means going in one direction at a certain speed, then it has a net force of 0. You can also look at the y-axis of movement, and the weight of the car pushes down the normal force, or gravity, and those two pushing against one another create a net force of 0, as long as we still stick with the stipulations that it is moving at a constant velocity. And then on the other hand, we've got, if we are inside a room, which we're not on this one, we're outside, the ones looking at this are air resistance. But you can also look at friction of something moving. The car does have friction, which is going to be a negative vector to a positive vector of the driving force, and those two together would create a 0 net force. All right, so today we're moving on to Newton's second law. Oh, and that says Newton's first law. It should say Newton's second law, which says the acceleration of an object is directly related to the force on it and inversely related to the mass of the object. This is the one that we said. An object in motion stays in motion unless acted upon by an outside force. And this is where we look at acceleration, where more force is needed to move an object, to move or stop an object with a lot of mass. And this is inertia. Remember, we got up in class together, and I had one of you strong football boys or one of you strong softball girls put all your force down that you could, put your weight against the normal force, and you were balanced, and I would come up against you and knock you over, and you would become unbalanced. That's when we learned about inertia. So some of you had more inertia than I did. We always said that the wall always had more inertia than any of us put together. It says then you need for an object with less mass. So for an example, if I have the force of 1 Newton pushing on a mass of a cart of 1 kilogram, it's going to have an acceleration of 1 meter per second squared. If I had the force of 2 Newtons pushing on the exact same block of 1 kilogram, its acceleration is going to increase to 2 meters per second squared because we've added more force to it. And then, but if let's say we take half away and go to half a newton of force to 1 kilogram of mass, then we're saying that its acceleration is only a 0.5 meters per second squared. Not everybody can do that in her head, so that's why we have an equation to figure out. So when we look at Newton's second law, we've got three variables. We've got our acceleration variable, our mass variable, and our force variable. If we want to find acceleration, we know that what we do know that we have to have is force and mass. If we want to find mass, we know that we must have acceleration and force. If we want to find force, we must have acceleration and mass. So hopefully a lot of you can remember the triangle method. We've already looked at this, I guess it was 2 weeks ago now when we were doing speed and velocity, and we used triangle method because it has three variables. And on this one, we're saying that in order for acceleration for Newton's second law, we're saying that in order to have acceleration, hold on, I gotta look back, that acceleration, there we go, acceleration equals the amount of force over the mass. The amount of force applied to the amount of mass of the object. And then the same thing for mass on this one though, we're saying that mass equals force over acceleration. But Miss Little, what do you mean? How are we finding that? Because we're using the overall equation that force equals mass times acceleration. I'm parentheses here to remind you that it's times. Because we can look at that, we say that our force goes on top and our mass and our acceleration go on bottom on our little tricky triangle that can help us see this equation. So if I wanted to find acceleration, I put my hand over the A and it leaves me force divided by mass because that horizontal line means to divide. And if I want to find mass, I put my hand over the M and what I have is force divided by acceleration because that means to divide. But if I want to find force equals my mass times my acceleration, because when I look at force, I'm saying that I'm multiplying the mass and the acceleration together. So let's look at some examples. So for example, the first one, how much force is needed to accelerate a truck with a mass of 2,000 kilograms at a rate of 3 meters per second squared? This little truck actually is the exact same truck that I had. I got my junior year of high school, had it all the way until my 3rd year of college. It was my favorite little truck, and it was called Blue Lightning. But let's go back and remember that we're looking at the equation that force equals mass times acceleration. We use our triangle. We've got force at the top, got mass and acceleration at the bottom, where this horizontal line means to divide, this vertical line means to multiply the two variables. So the first question I always ask myself in a word problem, this is not just for science, but for math, for any word problem that you have, we want to know what are we looking for? What is the question asking us to solve? And in this one, the very beginning, it says how much force is needed. And so if we're looking for how much force is needed to accelerate the truck, it's force that we're wanting to find. Well, if we want to find force, I need to know what is given to me in the word problem. Well, it tells me, first of all, that the mass of the truck is 2,000 kilograms, and it is moving at a rate of 3 meters per second squared, and we know that that is acceleration. So we're given mass, and we're given acceleration. So our mass equals 2,000 kilograms, and our acceleration equals 3 meters per second squared. And so what do we know? We've got to remember, if we're looking for force, which equation are we going to use? Where force equals acceleration times mass, or F equals A times M, or M times A. So now I'm going to solve using this equation and using these variables. So I can say that F equals A times M, where A is 3 meters per second squared, and M is 2,000 kilograms. When I multiply those together, I get 6,000, and it says it is kilograms times meters per second squared. And we know that these units actually mean 6,000 newtons. So in order to move this little blue truck that has a mass of 2,000 kilograms, the force needed for it to be at an acceleration of 3 meters per second squared, it must have 6,000 newtons of force pushing behind it. Let's look at another example. It says, what is the mass of an object that requires 15 newtons to accelerate it at a rate of 1.5 meters per second squared? Well, I've got to remind myself again that I'm using the equation that force equals mass times acceleration, with my force on top, my mass, and my acceleration on bottom. So the first thing I always do in a word problem is ask, what am I looking for? Well, right out of the gate it says, what is the mass? So I'm going to be looking for the mass of the object. Does it tell me what object? No, it's just a mass of an object. So then what is given to me? Then I keep on reading. It says that an object that requires 15 newtons to accelerate at a rate of 1.5. So it gives me 15 newtons. If you remember, newtons is force. And then 1.5 meters per second squared, which it already said, that is my acceleration. So that is what is given to me. I'm given force and acceleration. So force is 15 newtons, or my acceleration is 1.5 meters per second squared. So then I ask myself, okay, so what do I know? If I'm looking for mass, and I have force and acceleration, I know if I put my hand over mass over here, let's say that I'm looking for mass and I cover it with my hand, I have force divided by acceleration. So I'm going to use the equation that mass equals force divided by acceleration. So now I can solve. I've got everything. I've got my equation. I've got my two known variables to find my one unknown. So I can say that mass equals my force, which is 15 newtons, divided by my acceleration, which is 1.5 meters per second squared. And because I cannot do that in my head, I think it's 7.5, but just to double check myself, 15 divided by 1.5, it's 10. See, didn't know what that was. Equals 10, and it goes to kilograms because in all actuality, this newton is kilograms times meters per second squared, which means those two cancel off, and it leaves me with 10 kilograms. So in our line, I converted kilograms to pounds, and that would be the same. Look at this baby. That is the same mass as my little 10-month-old nephew, Asher. Isn't he precious? So it would take him about 15 newtons of force to move at a 1.5 accelerated speed of meters per second squared. And when he walks, it's the cutest little thing, this big old belly sticking out, and I just miss him plumb to pieces. And so his mass is right around 21, 22, and that could be wrong, but I'm thinking it's right at that. But he is precious. And I just wanted to show him off a little bit because I am missing him. All right, let's do practice number 1 for your homework today, which you will do 1 through 7. Let's do 1 together. It says, the question is, what is the acceleration of a 2,000 kilogram truck if a force of 4,200 newtons is used to make it start moving forward? I'm always going to remind myself, the equations I am using is F equals M times A, where F is on top, M and A are on bottom. So I'm going to say, what am I looking for? What is it asking me to find? And it says, what is the acceleration? There you go. I'm looking for acceleration of the truck. What do I know? Or what is given to me? It says that I have a 2,000 kilogram truck. I know kilogram is mass. And it says I have a force of 4,200 newtons. All right, so that is what is given to me is my mass and my force. So my mass equals 2,000 kilograms. My force equals 4,200 newtons. And why is there a decimal point at the end of 4,200? It's because it's letting you know that all four of those numerical numbers are all significant to this equation. So it's going to have 4 sig figs for the 4,200. And then what do we know? Well, we know we're looking for acceleration. We know we have mass. We know we have force. So if we're looking for acceleration, it's telling us to divide force by mass. So acceleration equals force times mass. So I'm going to set this up F over M. So if I'm going to look for acceleration, I don't know why I did big A. I apologize, because it's not area that we're looking for. It's acceleration that we're looking for. And so my force goes on top. It is 4,200 newtons divided by my mass on bottom, which is 2,000 kilograms. Remember, our newtons are kilograms times meters per second squared, which our kilograms are going to cancel off. I've got to get my calculator for this because I cannot do that in my head. I really wish. I guess I could if no, I'm not even going to try. Divided by 2,000. So I have 2.1 meters per second squared acceleration. Okay, so we have successfully together completed 2 examples and number 1 of the practice with you. So all you have to finish for today, all you have to finish today is numbers 2 through 7. That's it, just 6 questions. Make sure that you show your work. I know that when you turn this in, if you just shoot out some numbers to me and they're not correct, you better believe that Miss Little is going to be calling your parents saying, hey, they need to complete another AMI. So make sure that you show all of your work and at least that you are trying. So your assignment is to complete numbers 1 through 7. We have done number 1 together. Quick reminder, because I'm still receiving messages from students asking me when due dates are. So if you are okay with your third 9 weeks grade and you want to keep that grade for your fourth 9 weeks, those 10 AMI assignments, whether it's 2 through 11 or any 10 between 2 through 39, is due May 1st. Get those in by May 1st. If you want to increase your grade by 1 letter grade, you then need to complete an additional 10 AMI assignments and turned in by May 15th. Reminder, you cannot do 20 additional and think it's going to raise you 2 extra grades or 2 grades. We're only allowing it to go to 1 letter grade. So make sure you get those turned in. So those are your 2 due dates. Please do not wait to the last minute to work on these. Do not think that come April 28th, you can shoot out 7 classes, that's of 10 assignments, that's 70 or 60, 70 different assignments. You will be creating yourself some massive work and a lot of stress that should not be done and something you shouldn't have to be going through. So today's quote of the day: in an age of acceleration, nothing can be more exhilarating than going slow. And that's exactly what we're doing today. We're going slow. So hopefully you were taking the day to make a moment of something, helping your mom out or dad or grandma, or if you live with your sister or your brother, help them out. Tell them thank you for all they've done for you. Maybe you can clean up the kitchen tonight after they've cooked supper. Or you can cook supper. Oh, I don't know. Some of you might not be able to work the stove. Okay. Love you all. Have a good day. See you later.